Hi, welcome back to the channel. In this particular video, we're going to look at more problems on binomial expansion. So let's just get right into it. In this problem, we are asked to use the expansion of 1 plus x raised to the power 5 to evaluate 1 plus root 5 all raised to the power 5. I think this is quite clear what you have to do. Now, you can evaluate this directly, okay, if you like, but let's start with evaluation of this. So we notice that if you're using Pascal's triangle, we notice that the coefficient of the expansion to the power of 5 is 1, 5, 10, 10, 5, 1. So we can simply use that, or you can use the binomial theorem, which is any, so this is 5 combination 0, this is 5 combination 1, this is 5 combination 2, 5 combination 3, 5 combination 4, and then this one is 5 combination 5. So you can use any of those. All right. Now let's just use the Pascal's triangle. So this is 1. Then the first term raised to the power 5, the second term raised to the power 0. Then we have 5. Reduce the power by 1. Then increase the power of x by 1. Then we have 10 next. Reduce the power of the first term by 1. Increase the power of the second term by 1. Then plus again 10 is the next coefficient. So we are following the coefficients 1, 5, 10, 10. Reduce the power of the first term by 1, increase the power of this one by 1, and then 5 again. Reduce the power of this by 1, increase the power of this by 1, then 1. Reduce the power of this by 1, increase the power of this by 1. Okay. All right, so let's move a little bit. Now let's evaluate this. The first term would be 1, of course. The second term would be 5x. Next term will be 10x squared. Next one will be 10x cubed. Next one will be 5x raised to the power 4. Next one will be x raised to the power 5. It's as easy as that. Now, how do we use this in the expansion of 1 plus root 5 raised to the power 5? Now, check the two. What is similar is we have 1 in the first as the first term, which is fine. The second term is root 5, which is actually replacing x here. So all we need to do is what? Replace x with what? Root 5 in this expansion. Okay. When that happens, 1 plus root 5 raised to the power 5, using this expansion will now become 1 plus 5 times, because this is 5x, that will be 5 times root 5. The next one will be 10 root 5 square. Next time is 10 root 5 cube. Next time is root 5 raised to the power 4. Next one is root 5 raised to the power 5. Okay, cool. Now we just need to evaluate this. This is 1 plus 5 root 5. Now using SOD, root 5 square is 5. So 10 times 5 is 50. Now the next one, 10 times, so let's evaluate this one. This is something as 10 times root 5 times root 5 times root 5. So this times this is 5, right? So we have 10 times 5 times root 5. So that will give us 50 root 5. So this is how I evaluate this. The next one, root 5 raised to the power 4 will be 25, right? So 25 times 5 is 125. Okay. Then last one, root 5 raised to the power 5. So root 5 raised to the power 5, this will give us 25 root 5. So just check this thing out. So this is 25 root 5. Okay, brilliant. So what is next? We simplify, right? Remember, we are looking for the exact value in SOD form. So this will be 1 plus 50, 51, 51 plus 125, that is 176. So we have 176. Then what about the ones that have root 5? 5 root 5 plus 50 root 5, that's 55 root 5. Plus 25 root 5, that would be 80 root 5. Right? And this is the solution to the problem. Okay. Now, sometimes you might have a different type of expansion. So be careful. For example, let's say the question was find the exact value of this raised to the power 5. Which expansion will you use? You learn how to use expansion x plus. So let's say the initial expansion that you have is x plus 3y. So just as an example, let's say this was the problem and you are given to expand this. All you need to do is after you finish expanding this, which is 1x raised to power 5, x raised to power 5, 3y raised to power 0, you finish all the way to 1x raised to power 0, 3y raised to power 5. Let's say you finish this expansion. All you need to do is what? What will you substitute in this expansion? You substitute x equal to 2 and you substitute y equal to root 5. This is what you do in order to simplify and then get the equivalent of this particular expansion. I hope that makes sense, which is similar to exactly what we've just done in this particular problem. So try this one out as an exercise to see what you obtain. Okay, just try it out. Now let's look at the second problem. So what's the second problem? What is the coefficient of x cubed in the expansion 2x minus 1 raised to power 7? So question 2, we have 2x minus 1 raised to power 7. We're looking for the coefficient of what? Of x cubed. Now, how do we find the coefficient of this? Remember, we could write each term in this expansion as this 7 combination r. The first term raised to power 7 minus r, the second term raised to power what? R. So we just need to find the right value of r that will give us raised to power x raised to power 3 in the expansion. It turns out that what? This power must be equal to 3, right? It means 7 minus r must be equal to 3 so that we will have x raised to power 3 in this expansion. So this means r must be equal to 4. Okay, so we make r equal to 4. That will be 7 combination 4. 2x raised to power 7 minus 4, which is 3, then minus 1 raised to power 4. Okay, so this gives us 7 combination 4, 2 raised to power 3, x raised to power 3 minus 1 raised to power 4 is just 1. So your answer will be 8 times 7 combination 4 times x raised to power 3. So these numbers, when multiplied together, would give us the coefficient of what? X raised to power 3. Is 8 times 7 combination 4. So this is your final answer. Okay, I hope this makes sense, and I hope you have learned the technique that would help you to find the coefficient of any variable in an expansion, in binomial expansion. This brings us to the end of the video, and I will see you guys in the next one.